morning, everyone, and welcome to this talk on streamlining large-scale Java development using Error-Prone. My name is Sander Mak. I work with Picnic, the online grocery scale-up here from the Netherlands, and you've probably already seen this cute little vehicle in the hall down there. If not, please come by. It's really nice to see, and maybe you can even sit in it if you ask nicely. But we're here to talk about Java development at a large scale. I do have a few warnings or disclaimers, so to say. So if you've been at JFall, you may have recognized the title, and yes, it's indeed the same talk, but we did get a lot of positive responses, so we also wanted to share this with the JSpring audience. So if you're here and you've seen this before, please leave, feel free to, I won't be offended. Also, not a fair warning, after this talk at JFall, 2 people actually ended up working at Picnic from that audience, so also a fair warning here. If you don't want that, also free to leave, I will not be offended. But anyway, we are going to talk about Error-Prone, and I also have a little bit of a dirty little secret from conference speakers to share with you. Because we love talking about big new things, right? You need to move to Kubernetes, you need to do microservices, you need to move to Kotlin, you need to do this. That's all great, but how much of that can you actually use in your day-to-day job? Often not very much, right? What I'm going to talk about today is a tool that you can take with you tomorrow already to your team, and you can apply it on any Java code base, and it will make it better, I promise. So that is actually a superpower that I'm going to teach you today. Can Java developers have superpowers? Yes, they can. And the superpower that I'm talking about today is the ability to refactor your code bases at scale. And with refactoring at scale, I don't mean that you teach all of your developers to frantically use all the shortcuts in IntelliJ. Yes, that's also very important, but this is about doing it using code, right? Because if we want to do things at scale, we need to automate, and we need to do it with code. So Error-Prone is a tool that allows you to do this. And this is a tool that we have not created. It's actually open sourced by Google a couple of years ago. Not that well known in the community, sadly. So this is also why I wanted to share this, how we use this at Picnic with this audience, or with this group of people, so that you can also take advantage of this open source tool and start applying it in your own code bases, right? Before we go there, why does Picnic need this, right? What does Picnic have to do with Java? Well, as an online groceries company, we actually write a lot of software. There's obviously the backend for the app that we need to run, but there's many more processes, like ordering our groceries, making sure that we have the right routes for our vehicles, making sure that we pick the right groceries in our warehouses so that the orders are fulfilled. All of these processes and all of these systems are written by the Picnic tech team using Java. So obviously, there's a lot of Java development going on in our team, and we want to streamline this as much as possible, especially given the growth that we are facing as a company and as a tech team. So to keep our sanity and to keep our code bases clean and nice and easily extendable, we wanted to use tooling like Error-Prone, and we'll also see some additional tools later as well. This means that as a company, we're not that old yet. We started 7 years ago. Currently, roughly 200 engineers are working on these systems that I talked about. We even built systems to automate our first warehouse, so controlling robotics, etc., etc. So there's a very wide range of software that we're building using Java. That is to say, we have a lot of code. And as you know, code needs love, right? So you need to keep paying attention, you need to keep improving it in order to make it maintainable and extensible towards the future. Well, if we want to do that, we have SonarQube, right? Problem fixed. Well, not quite. It's not a bad tool, but if you have this fancy dashboard telling you have 80 days of technical debt, what does it even mean, right? And there's a lot of tuning and tweaking, etc., going on if you're using SonarQube, which is all great. And it tells you a lot about the trends in your code base, but it's not that close to your development cycle, usually. So we wanted something like this, but better, and closer to our developers, and closer to our development cycle. There's other tools as well, of course. So SonarQube helps you a bit to understand your code bases and to see the trends that are in there. But there's also more specific tools like spot bugs and check style that you can actually hook into your builds that will yell at you when you do things wrong. And that's already an improvement, right? Because it helps you to prevent things from getting worse in your code base. It prevents you from applying some anti-patterns or some bugs, introducing bugs in your code. So that's pretty good. But what we want to do is we want to even go a step beyond that. Not just have a tool that yells at you if you're doing something wrong that somebody else thought of, but also being able to define your own patterns about how we think software development should be done in Java, and apply that in an automated fashion to all of our code, in all of our pull requests, in all of our processes. And that tool is error-prone. And together with Refaster, another project from the same stable at Google, we'll talk about a bit later, we can do a lot of this in an automated fashion. So what is error-prone? It is actually a Java compiler plugin. So can the Java compiler have plugins? Well, yes, it can. It's not that well known of a functionality, but this is a very, very good use case. Doing static analysis and even doing improvements to code is a very good use case for creating a compiler plugin. And as a compiler plugin, you can easily hook it into your Java compiler in any build system. Doesn't matter whether you use Gradle, Maven, or any other exotic build system. You can just configure it as a compiler plugin and be done. It supports Java 8, 11, and Java 17, and the latter is also pretty important for us because we migrated to Java 17 a couple of months after it was released, so all our tooling needs to be able to support Java 17. And it comes with a very large set of predefined bug patterns that it can detect. And in this sense, it's a bit similar to spot bugs, for example, that we talked about. The checks are a bit broader. They're not just core Java. There's also some library-specific checks in there. But out of the box, you already get like 500 of these bug checks that error-prone can detect for you and can help you to spot errors. And in fact, if you go to the error-prone site, you will find this testimonial by Doug Lee. That's the guy who created the Java util concurrent libraries, where he says, okay, well, it's a bit embarrassing. I guess I'm back to liking error-prone, even though it sometimes annoys me, because it found a bug in the concurrent hash implementation. So I think that's a pretty good endorsement. And it also shows that, yes, we as developers don't really like these tools, even though we know it's like eating your vegetables, right? You need to do you need to apply these tools, but in the end, they're just a bit annoying and yelling at you. But we'll see how we can give our own twist to that and make it a little bit more bearable. But instead of just talking about error-prone, why not just have a look at some code, right? And have a look at some examples. So what I'm going to do is I'm going to switch to the IDE, where I have a very simple class with a main method, and there's some code in here. And there's sort of an issue with this code. I mean, we can see that it's valid Java, right? So there are no red squiggly lines. It even compiles. So if we say maven clean verify, then it will just build OK. But there's something not quite right with this code. Does someone see an issue here? Yeah, shout it out. Exactly, the exception, it's created, but it's not thrown. So this is valid Java code, but nearly every time you see this, it will be a problem. It will be an issue, right? It's not what you actually meant as a developer. So what I'm going to do as a first step is just introduce error-prone to this code base. And like I said, it's a compiler plugin, so we need to add it to the compiler configuration. And if we then insert this snippet, you can see that we add some compiler arguments to the compiler configuration and an annotation processor path where it will look for the compiler plugins. And in this case, we're adding error-prone core as a dependency here, and we're setting the plugin error-prone active with this flag. We also need to configure the compiler to use a simple compile policy, which is sort of an implementation detail of the Java compiler. There's a JDK bug open that, when fixed, would not require this flag anymore, but until that is fixed by the JDK, we need to set this for error-prone to work correctly. So by adding this and running the build again, we will actually see that we get an error, and not just a plugin error from Maven or whatever, it's a real compiler error, right? Because it works as a compiler plugin. And it says, okay, there's on line 825, and I can just click this because it hooks into IntelliJ because it's just a compiler error, goes to the right location, says there's a dead exception, right? It's an exception that's created but not thrown. You can even check out some more information here. But the cool thing is, it actually tells us a very context-specific suggestion, right? It says, did you actually mean throw new illegal argument exception? Well, yeah, that's indeed what we meant here, right? That's what we wanted to do. But then you start thinking, if it can actually give this suggestion to us, so on the command line in the error message, why wouldn't it be able to actually apply this for us? And that's also what error-prone can do. So we can run it like this, just as a plugin to spot errors and to find errors. But because it can also create suggestions, we can also ask it to actually apply these suggestions. And we can do this by configuring error-prone into the so-called patch mode. There we go. And then we say, okay, we want to enable the following checks, in this case, the dead exception check, but you can list many more there if you want to. And then you can either output a patch file with the suggested change, or you can say, okay, I want to do in-place patching, which is for this demo the nicest thing to do, and it can just fix your code in place. Now, if we run the Maven build again, using this configuration, there we go, and we would switch back, then, ta-da! It says throw new legal argument section. That's pretty cool, right? Yeah, I think it's very, very cool. So instead of just having a tool that tells you you're doing it wrong, it actually fixes it for you, which is, I think, a pretty nice thing to have. It's a little bit like autocorrect on your phone, but better, I would say. So using error-prone this way is already a very, very interesting step, right? So you get a lot of bug checks out of the box, and it can also apply these bug checks and the fixes for you if you want to. And the cool thing is, these checks that are bundled with error-prone are not just about core Java. So the example that we saw was a core Java example, of course, with the dead exception. But there's also some Android checks. There's JUnit library usage related checks, even Joe the Time, although that's a bit outdated, of course. But there's not just core Java checks in there, and there's more to life than just core Java in error-prone. That is to say, if you want to use error-prone, you probably also want to customize it a little bit with the checks that come out of the box. So on the one hand, you can also tune the severity level of the errors that you get. So if you see one of the patterns and it comes as an error, and you say, okay, I just want it to be a warning, you can do that by saying XEP and then the name of the check and giving the intended severity that you want. You can also turn checks off, which, for example, we do because we're building backend services, so we don't want to waste CPU cycles on the Android checks that are in there. So the way to turn it off is by naming the check name and then saying off after the colon. But it might also be that you do want to enable a check, but at some point in your code you do want to make an exception, either because you actually want this code to be there, or because you're just not ready yet to refactor it and to rewrite it, and you want to allow it for now. And for that you can use the Java's suppress warnings mechanism, so the regular mechanism to also suppress regular Java compiler errors can also be used with the names of error-prone checks. Because again, it works as a Java compiler plugin, so it hooks very directly into the compilation lifecycle of Java itself. All right, so that is about using error-prone out of the box. So one more thing that I think is very, very cool about error-prone, it's not just about bug patterns. So there's some other checks in there that are very useful that we, for a Picnic, also use. So one of those examples is using the var check. So usually you may have these annoying coworkers who are saying, okay, immutability is great, right? We need to make everything immutable because we can reason more easily about it. It's more easy if you are working with concurrent code, etc., etc. And you know they're not wrong, but still it's pretty annoying if you need to make everything final in Java, and then it gets a bit noisy. So what you can do with error-prone is flip it around and say, okay, by enabling this var check, you assume that every local variable and every parameter in your codebase is final. But if you do want to reassign to this variable, you can, but only if you annotate it with @var. And that's what we use. So we do have a few places in our code bases where you see this @var annotation, and you think, well, why is it there? It's always a good trigger to think about whether you really need this reassignment. But the default will be for all variables, all local variables and parameters to be final and not be reassignable, which in the end nudges us towards immutability without all the noise of introducing final everywhere. That's another way of using error-prone, which is not so much about bug patterns, but about tweaking the way you work with the Java language. Now, there's a lot of things that come for free when you use error-prone out of the box, as I've shown. And there's also some contributions that you can put on the annotation processor path that will give you additional checks. Mostly library-specific checks. So for example, the Mockito team also provides error-prone checks that you can put on the annotation processor path if you're using the Mockito library in your tests. And it will apply these bug patterns that are specified and maintained by the Mockito team. And the same, there's something for slf4j, and then there's more. So there's a whole ecosystem around these checks which allow you to tailor it towards the libraries that you use to get even more mileage out of using error-prone that way. But wait a second. If they can create these kind of bug patterns and these bug checks, then we should be able to do it as well, right? And indeed, that's the case. So error-prone is also very, very much extensible. And how do you introduce such a new bug check? By creating a class that extends BugChecker. And I'm going to show an example of this, but I first want to explain the structure a little bit. So I'm going to introduce a new Maven module, a new project called my BugChecker plugin, which will contain this empty method checker. And we're going to create a little error-prone check that just tries to look for empty methods in classes and turn that into a compiler error, because we might not want that in our code bases. So what happens then is that once we created this my BugChecker plugin and put it into a jar file, we can put this jar file on the annotation processor path of our original buggy app application and start using this bug check. And how does error-prone do this? Well, it tries to discover bug checks using the service loading mechanism that is in Java. And I will be using Google's auto service library to make it easy to make the BugChecker service loadable, so we don't have to create the meta-inf directory with some kind of wonky file in there. And then the original way of using services is quite verbose, I would say, but using the auto service tool of Google is pretty straightforward. So let's see what that looks like in the IDE. So this is my second project, my BugChecker plugin. And looking at the Maven POM file, you can see that here we don't have error-prone itself defined, because we don't want to go all inception, right, where we check our checks. But I do have the auto service annotation processor here, so that we can use the auto service mechanism of Google to make the BugCheck service loadable. Then we're going to code against some of the error-prone APIs. So we do have some dependencies here in our POM file that we need to use, and also the auto service annotation comes from this dependency. So that's more or less the setup that we have here. Now we're going to create this bug check, this custom bug check. First, we need to make it service loadable. So let's give it the auto service annotation and tell it that it can be discovered under the BugChecker.class type as a service in this Java service loading mechanism. And then we also need to tell error-prone a little bit of metadata. So the name of this bug check will be empty method. There we go. And we should give it a little bit of a summary where we say, okay, we don't like do nothings. There you go. And we need to give it a severity. And well, let's just make it a compiler error to have an empty method for now, right? Because we can. What we need to do now is implement the match method here. And a bug check, a error-prone bug check, works like a visitor pattern, right? So error-prone itself traverses the abstract syntax tree of the Java code that is being compiled. And it feeds it into any bug checks using a visitor pattern. And here we have indicated that we want to implement the method tree matcher interface, so we're only looking at methods. Now, what we want to do is we want to check whether the method tree body has statements, and if it's empty, then we want to flag this as an error. And for that, we can use the describe match helper method that's on the BugChecker class. And we indicate, okay, this is a match that applies to the method tree that was just passed into this method. And we can provide a suggested fix. And the suggested fix, in this case, is to delete this node. So we want to delete this method. There we go. And as you can see, we're not talking about source lines of code or doing anything like that. This is all AST-based kind of programming. And the translation into actual source lines and translating into a real fix and a patch is all done by error-prone itself later. If there's no empty method, then in this case, we'll just return a description no match, meaning that error-prone will just keep on going until it does find a match. So we've created this. Now we need to install this to our local Maven repository, because remember, this is a standalone project and it contains the BugChecker plugin. This will create a jar file that we are going to add to our other project. And to do that, I'm just going to copy the coordinates of the BugChecker plugin here. And we're going to move to the buggy app again and add it to the annotation processor path that we have here. There we go, path, add the dependency. And this way, it will find this class, and it will see that the server is loadable. There's a quick question, hopefully. Woo, there we go. You mean in the... that's a pretty good point. Thank you for that. And let's rebuild it. Yeah. Very sharp. Very, very sharp. There we go. And then we should be able to do the same trick still. So we have it configured in our POM file as a dependency. We also need to add it as an enabled patch check here. Empty methods. There we go. And if we now run Maven clean verify and go back, poof, it's gone, right? The empty method that was here. So thank you so much for the sharp observation. Otherwise, we would have to do this again. Yeah, so again, we created our own bug check with a suggested fix. We saw that it was removing this method. So that is one way to implement something that you want to do yourself. So obviously, if you're going to do this in production, you need to be a bit more deliberate, right? So maybe you would want to check if there's an override annotation, because then it's supposed to be empty sometimes. And there might be more edge cases. But this is the general mechanism on how to do this. Oh, let's go back. But if we undo this and we get our do nothing method back, and we actually go back to error prone and just run it in checking mode rather than in patching mode. There we go. Run the build again. Then you see a compiler error, right? And it says, okay, that you mean to remove this line. So you actually create your own Java compiler error using this error-prone bug check, which I think is a very, very cool thing to be able to do in such a straightforward way. All right, so let's move on to our presentation. Here we go. So what do we use this for at Picnic? Because we do have quite a few custom bug checks in our code base. And there's actually 3 categories of checks that we have. So one is more about trying to find correctness issues in code. And one example there is that we have a bug check that goes looking for maybe places where we use time APIs in a way where we don't really care too much about time zones. And we forget, and we maybe just call the default zone, or we rely on local datetime.now without any injection of, for example, a clock, which is the usual way that we want to do this in code. So that's a check that really is very specific to the way we want to structure our code around using datetime APIs. So it checks if you use any of the local datetime now. It will tell you, okay, please use clock, or in Java 17, actually instant source, which is a new API, to actually get the current time so that we can mock it and that we can also use it, and also for APIs that we don't rely on the default system time zone. Another category is where we want to try and spot runtime errors or runtime issues in code bases. And one example is sleft4j, which is a great library, but it's sometimes misused by developers. Here's an example. On the left, you can see that there's a log statement with a placeholder %s, which is actually not the placeholder syntax that you should use with sleft4j, right? You should use these curly braces as placeholders. But this is not a compile error. This is will just run, and it will just log %s, which is not what you meant because you wanted to have the count. So what we have is a bug check that actually inspects the string that we log and see if there's any stray usage of this %s in there, and tell the developer, okay, I think I know what you're doing, but you're doing it wrong, and please change this to use the right placeholder syntax. And similarly, we can also detect, for example, if you have 2 placeholders in your log statement and only 1 parameter, well, it will compile, it will run, it will actually log and do something, but it's not doing what you want, right? So we have a check for that as well. So these are things that you can help in the way people use or abuse APIs. Then there's the last category of checks. This is more about code style. So what we see a lot in code, where this was usually discussed a lot on PRs, etc., where people use the value is syntax, and you can just leave that off, right? If it's just a single value that you pass to an annotation, or where people were using the array syntax into an annotation, even though there's only 1 entry. And we will really value having some uniformity and some clarity around that. There's also the trailing comma there, which is legal, actually, but it's not very nice. So these are all things that we can flag using the custom bug check that we created for this, and that also can get automatically rewritten by error-prone, as we saw by having this bug check. So all in all, there's various ways to use error-prone, and it's up to you, of course, to decide how far you want to go and what you actually care about in your process. But there's also a couple of things that are not so nice about this setup. I showed these examples to you, but I only showed the header, right? Only the annotation that was on top of the class. What's in there is actually can be hundreds of lines of code to do the tree traversal, and the more complex your check becomes, the larger this BugCheck class is, and it's also using AST manipulation, which is also not for the faint of heart. And everything can be learned, of course, but it's quite a steep learning curve if you want to really write these complex checks. So all in all, it brought us a lot of good, but it's also quite challenging to keep extending this and to also onboard new developers into this tool. And especially if you want to emit good replacements for the checks and the things that you're detecting, it can really get out of hand in terms of the code that you need to write for such a bug check in error-prone. But what if we could go a step further, where we're not writing this tree traversal code that we just saw, and that we don't have to manipulate the AST by hand, but where we could just say, okay, I have some piece of bad code, old code on the left-hand side, like if I check if it's equals to an empty string, and I have a way I want this code to look like, where I say, okay, this needs to be turned into an isEmpty call, because it's more intention revealing, it's actually using the API as intended. And that's also possible using error-prone with an additional tool called Refaster. So I want to show an example of that as well. So Refaster allows you to create a class with a method annotated using before templates and a method annotated with after templates. And there, in these two methods, you can just in concrete Java syntax write the old pattern and write the new code, so what you want it to look like. And then under the hood, Refaster and error-prone will figure out how to actually pattern match on that kind of code and how to rewrite that without you having to implement this bug check and without you having to write all this AST tree traversal code. So how does this work? You compile this again using a special compiler plugin, not the same one as we saw, but a different one, that compiles this template class. And we actually disregard the class output from this. But as a side effect of compiling using this special compiler plugin, we also get this empty string.refaster file. And this is sort of a recipe that can be picked up by error-prone and that can be applied to any other code that you run this over. So the goal here is to be able to, in concrete Java syntax, define the before and after, turn that into a Refaster file, and then we're going to feed this Refaster file into error-prone, and it can be used to do the same sort of rewriting that we just saw, but now in this case not based on a BugCheck implementation, but just based on this before and after template. So let's have a look at that. So we have the third Maven project here called My Refaster Template. Looking at the POM file, you can see that we indeed have a compiler plugin configured again, but in this case it's the Refaster rule compiler plugin, which in this case outputs into an empty string.refaster file, which we will use subsequently in our buggy app to do the rewriting. We need to put error-prone Refaster on the annotation processor path, because that's the one that compiles the Refaster rule compiler. And other than that, we also need to add the error-prone Refaster API as a dependency, because, well, that's where the before templates and the after templates and all the other APIs live that we are going to use here. So I have this string is empty template class, and as you can see, there can even be multiple before templates. So we say, okay, if we see some piece of code where there's some kind of expression of a type string, it doesn't have to be a single variable, it could be a whole chain of expressions which in the end returns a string, as long as it's something that is of type string, and then we see dot equals literal empty string, that's when we want this template to match, right? Or if we see, again, some kind of expression where of type string, where we call dot length equals 0, then we also want to match. What we don't have yet is the after template, right? So I'm going to add this. There we go. Where we say, okay, in this after template, we have the write code. So that's what we want to rewrite to. And there's also this also negation annotation, which will also match the not case. So if it's inverted, which is also what we want in this case. And then we want to rewrite this to string is empty. And that's all we need to do for this very simple case. So let's say maven clean compile. And if we now look in the directory, there should be indeed an empty string.refaster file. And if we then move back to our buggy app, and we get back to the configuration here, and we add, in this case, the patch checks again, but rather than referring to the built-in or the custom names that we have, we are referring to a refaster file, which we just created, the empty-string.refaster, and we're still doing in-place patching because, well, that's the way it is most visible what is happening. As you can see here, we have this args0. So this is the expression of there we go. This is the expression of type string dot equals empty string, and we would expect this to be rewritten to our new code. So let's do this. Verify. There we go, and poof, it is empty. Right? That's pretty cool, and this is something that is much easier to use, of course, than creating these bug checks that we talked about before. So can you just do expression rewriting? No, you can also do lists of statements. So here's a before template that matches the, let's say, the canonical way of swapping items in a list, where you would have a temporary variable. But there's actually also the collections.swap method. So it would rewrite to this collections.swap. So it would rewrite 3 statements into 1. But they need to be consecutive statements, and they need to be matching the way that we have it here. So what do we use it for? Well, at Picnic, like I said, we like to migrate as quickly as possible to newer versions of Java. So we migrated to JDK 11 pretty quickly, also to Java 17. But it's one thing to swap out the JVM and just run on the new version. It's another thing to actually make use of the new APIs that are in there and then make use of everything that's improved. So that is one use case where we use a lot of refaster. So for example, in Java 11, they introduced this optional .isEmpty method, right? And until then, a lot of code was doing not optional is present, which works, but it's much nicer to read this optional is empty instead. So you could go manually in your code base and change it everywhere, which is a bit risky and error prone. But if you actually do this, then it takes a lot of work, and people don't have time for this. You can also do the Boy Scout rule, of course, and say, okay, if you touch a piece of code, and then you are allowed to improve it, but then you need to think of it, and you don't touch all of the code all of the time. So this is a very nice way to just in one fell swoop migrate your whole code base from the old API to the new API. And this is in fact what we did. And this is a real template that we have in our code base. Another example showing that it's not just about core Java APIs, but in Java 11 they also introduced the stream method, an optional, where you used to do first a filter on a stream of optionals saying, is something present? Okay, and then we map the get over it to get all of the non-optional elements. Now you can just say stream flat map optional stream, which again is a nice rewrite that we can apply everywhere. And the interesting thing here is that there's not just the idiom on the top, so filter and then map. There's also stream.flatMap, streams : stream, which is a Guava method. And we also use Guava as a collections enhancement library. But we also want to get rid of that, because if it's in the JDK, we much rather use the JDK method that is there. So you can see that this rewriting doesn't just work on core Java APIs, it works on any API. Refaster any of, by the way, is an alternative way of expressing these multiple templates. So if any of these two match, then it will be rewritten to the after template. Another example, we also use Reactor in some of our services, so the reactive programming API. And over time, you will find that there's some anti-patterns that creep into your code. And rather than discussing this in every pull request every time and maybe missing a few, we strive to encode these anti-patterns as rewrite rules using Refaster. So this is an example where At some point, if you had this mono and you map an optional over it and then do default of empty and give it an optional, the example here doesn't really matter too much. But again, it's the way an API, an external API, is used in our code that we're not really happy with, which means that we can write a template, say, okay, if you see something like this in the code base, please rewrite it to that. And in this case, there's this toOptional method, which is a static method. If we would rewrite without adding an import, then it would not compile. So there's also this use import policy annotation that you can use to direct Refaster and error-prone to actually add this static import so that the code is still valid and still compiles. So when would you use Refaster? I give a lot of examples, right? So usually when there's a newer or better version of a certain API invocation, that's a really good use case to write this Refaster rule and to do this migration automatically. You can also use it to migrate a sequence of statements, as I showed. That is not something we do very much, but occasionally it can be interesting to think about these kind of rules as well. And especially if you have these chains of nested of chained invocations, and you have this a lot when you, for example, use the Streams API or the reactive kind of APIs. That is also a prime use case for rewriting using Refaster. But there's a trade-off, right? Because Refaster is not as expressive as writing these bug checks yourself. If you implement these bug checks that I talked about, you have much more freedom about what to look for and what to rewrite. So there's a time and place for both, I would say. So on the one hand, Refaster, it's much easier to work with. It's the concrete syntax before and the after. It's really easy to understand. But it does not apply to all situations. And it's also only just for refactoring. And sometimes you just have a bug check where you don't really have a suggestion, but you just want to flag something, right? And that's also the place where you would implement a bug check rather than use Refaster. Because in the bug check, as we saw, you have the full power of the whole AST that you can traverse and that you can manipulate, which can be a bit intimidating, but at the same time, it also gives you a lot of flexibility and a lot of room to implement some intricate checks there. So if you go to the error-prone website, there's actually this nice page where it says, okay, when do you actually want to create a bug check? And what's sort of the criteria? And then if you want to also contribute it back to error-prone, what should you think of? And they really want to focus on the low-hanging fruit for the checks that they include in error-prone core, I would say. So the bugs should be easy to understand, the fix should be fairly local and easy to make, because you can go all out in the bug check if you want to, but that's really not what you should do. And it's sort of summarized as if you create this bug check and someone enables it, they should feel happy about it, right? They should think, wow, I'm glad I added error-prone and did this to my code base. I'm glad that error-prone caught this for me. And that's also something that we try to keep in mind. Of course, if you make your own specific rules, you can go a bit further than if you want to really contribute back to error-prone itself. So in that sense, this is more of a guideline. But yeah, always keep in mind that the tool is there to serve us and not to be too complex. So finally, how do we actually integrate this into our way of working? So of course, people can run these bug checks and these error-prone rules locally. And we encourage that, and we want people to do that in their local builds. But of course, things can be pushed without that having run. So we also want to catch this in our continuous integration cycle. And what we do there is actually fairly simple. So once a push is made to a branch, to a pull request, we build, we run error-prone with all the bug checks and the Refaster rules in patching mode. And if the git diff is empty, so if nothing has changed, then we're good, right? If not, then we actually post a comment to the pull request. We ensure that it cannot be merged, and we use Danger, which is a very nice integration tool with GitHub and in your build to be able to do this. And that's the way that we apply this, right? So usually developers run these checks locally and apply all the fixes themselves. But if they haven't, they will be caught out by the continuous integration server. And they will have to apply all of these checks and all of these refactorings before it can be merged into the main branch. So that's fairly straightforward, but it does allow us to enforce everything picnic-wide, right? So all of our code actually conforms to all of the checks and all of the refactorings that we have defined. So when we started using this, we were so enthusiastic about it that we even wanted to go a bit further. Because what you saw with Refaster is that it's very, very nice, but it's also a bit limited in scope. What we also wanted to be able to do is, for example, refactor our usage from old RxJava reactive code to reactor. And we could already do this a little bit with error-prone the way it is. But if you start using it, then you will encounter at some point, for example, that you also want to rewrite return types of methods, because at some point you're going to return some reactive type. If you're migrating all the expressions, then at some point you also want to migrate the return type. And that's really not possible with the current Refaster implementation. So some people from our team actually studied this a bit and came up with a solution, even led to a very nice paper at a conference. So we now have an extended version of error-prone that is also able to do much nicer, much bigger, and much more complex migrations, like, for example, the RxJava to Reactor kind of migration that we have within our company. So I should also be fair and tell you that we do run a fork of error-prone to support these kind of developments. But the nice thing is it's open source, so you can also use this. And if you are actually going to use error-prone, not just with BugChecks that are in there by default, but also with Refaster rules and your own Refaster rules, I would recommend checking out this fork because we have some, let's say, ease of use enhancements to error-prone that make it easier to work with a lot of Refaster rules. We also contributed a lot of improvements already to error-prone core. But not everything has been accepted yet, so that's why we still run this fork. Also, if you want to go really in depth into error-prone, I highly encourage you to reach out to Stefan Schroefes, who's very much involved with this effort in Picnic and is also part of the platform team efforts that are behind this, because we do have a team that is really dedicated to actually having top-notch Java development tooling for all of our teams, and maintaining error-prone and some of these Refaster rules, etc., is part of their job. So if you're interested in that, definitely reach out to him. But also, I will be here today and happy to have a chat with you as well. Now, if you liked what you saw, then I hope that tomorrow you will be able to actually start using this, right? Because it is really something that can be slapped onto any code base. And of course, it will take some tweaking and configuration to see what works for you in terms of the checks that are in there. You don't have to go all out with custom checks and custom Refaster rules from the beginning. But it is a very nice tool to adopt and to have this as sort of a vision to move into. So I hope you are inspired to do that. Also, if you like what you heard about how we do things at Picnic, please do come by and happy to have a chat with you. Would love to work with some of you, maybe as part of a platform team or maybe in another way. And with that, I thank you all so much for your time, and I wish you a really great rest of JSpring.